A very good evening and a warm welcome to everyone present. Today, we all have gathered here to witness our 14th Centenary Lecture from the Centenary Celebrations. Today, our lecture will be delivered by Mr. Debiprasad Palit on the topic, a fun walk through mechanical design. Today, as the chair of our session, we have with us Professor Shishir Kumar Guha, former professor, Department of Mechanical Engineering, IIEST Shibpur. I would request Sir to take over the session as the chair. Over to you, sir.
Good evening, everybody. Warm welcome to this 14th Centenary Lecture session. And thank you for giving me the opportunity for chairing this lecture session on behalf of the department. I wish to thank Professor Vidyut Pal for acting as the convener of this lecture session and also our present head of the department, Sudip Ghosh. Now today we have with us Mr. Debiprasad Palit as a speaker. Now prior to his lecture in this session, let us first introduce him before you. Mr. Debiprasad Palit obtained his bachelor degree in mechanical engineering from Bengal Engineering College, Shibpur in 1967. Later on, he received the MTech degree from IIT Kanpur in 1969. Mr. Palit started his professional career at Hindustan Machine Tools, Bangalore, in the Metal Cutting Research and Development Center as a fresh engineer of a team who designed and developed India's first CNC turning machine and machining center. He also served several reputed Indian companies like Tata Motors, Mullins of India Limited, where he carried out the design and development work of a wide variety of metal cutting machine tools and packaging and plastic processing machines, and all electric plastic injection molding machine. Mr. Patil retired as Vice President Technical of Lohia Sterlinger Limited, Kanpur, where two notable developments under his leadership were high-speed plastic tape extrusion and stretching line of a special purpose cam control milling machine for machining. In the post-retirement, he worked as a consultant and project director of Design Engineering Machine Solution Limited, Pune. And there he led the special equipment group involved in design, development, and supply of some unique equipment for use in the Government of India, defense establishments, and Indian automobiles companies. So it's seen that Mr. Palit has extensive working experience in the area of design and development of machineries in the various industries. Now I would like to request Mr. Palit to deliver his lecture entitled as a fun walk through mechanical design. So please start your lecture, and time allotted 45 to 50 minutes.
So I unmute myself and then I have to go to share straight away for the PPT. Yeah, screen. Where is that screen? Yeah. Okay, I think I am audible at the same time. The screen can be seen. Only thing, the screen covers, this small icon covers part of the screen. Am I audible?
Yes, sir.
Okay. Okay, let me begin. Thank you, Professor Guha, for your kind introduction. And right at the beginning, I'd like to thank Dr. Sudip Ghosh for giving me this opportunity to talk on this occasion. and Dr. Ashok Mullik for recommending my name for this talk. I also congratulate all the members of the celebration committee and the present mechanical engineering department for the huge work they are doing for this particular celebration. 100 years of existence of a department of one of the most reputed and oldest engineering colleges in India. So it is something, an event for a lifetime. Now, today I don't find my professor, Dr. Amitabh Ghosh, amongst the audience, but I find number of dadas, I think they are there, who are even older than Dr. Ghosh and senior to him. In fact, it so happens that some of these dadas, they happen to be classmates of my another professor in IIT Kanpur, Dr. Jyotsnamay Chakravarti. Anyway, then in the audience, there are my formidable classmates, and quite a few of them are very reputed academicians, then researchers, corporate honchos, and then the last but not the least, there are my juniors who are very distinguished in their own area of work. Now I have to talk in front of them, and and they have already delivered 13 lectures. So I'm afraid after their lecture, maybe mine will sound like light music after pure classical music. But anyway, I thought that I will manage the situation by not acting like an expert, which in any case I'm not. So rather, I will be a storyteller. I will tell stories of various engineering design, particularly in the field of mechanical engineering, from various fields in which I have been part of. So with that, I start. And in any case, I have to hurry because I know many in the audience, they will be just will be waiting for their dinner. So let's start. The theme, only problem is you can see the part of these things, is it getting obliterated or the screen can be seen fully? Is the screen seen fully?
Yes, sir.
Okay, fine. Thank you. So theme of my talk will be, if mechanical design is not practiced mechanically and free-flowing thoughts, playful thoughts are applied right at the beginning to the need and the conceptual aspect of the design, then a lot of fun can be derived. Now, so my course of the talk will be like this. So it is about the conceptual aspect of mechanical engineering, mechanical design, taking actual examples from areas like, I'll give just a few examples of design of simple utilities and goods. Then I'll go to design of machines from fields like packaging, cigarette making, metal cutting machine tools, and special purpose machines. Number of examples. Now, with the fun of success in designing these machines, that is, there are things which are not so fun. Those are goofing up design. It falls in machine design. I'll just give two examples. And then, with the permission of the chair, I would like to take just 5 minutes to touch a bit of 2 points. And they are from, why I want to talk about them, because these points came up for discussion in some of the previous lectures. I hope I get that extra 5 minutes. Now let us see some utilities and product design, just some examples. Now, you know, every housing society, an institute or a hospital, etc., they have got a compound wall and a gate. Now, if the gate remains open without supervision, then people can walk in, ride in, or drive in freely. However, with that, some cattle, goats, and pigs also can walk into the campus. The question is how to design a system to guard against such undesirable visitors. Now, very simple thing is to you employ a guard, and then he will be opening or closing the gates depending on who is trying to enter. and we can reduce his fatigue by motorizing the gate or making the gate of some light construction. A more sophisticated solution, which probably will be done by today's young engineers, an automatic power-driven gate, CCTV cameras, a reliable image processing software, and an embedded some logic circuit to differentiate animals from people. And depending on the result we get, the gate will be opened automatically to permit entry of the right type of living being. Now, against this, one design which I happen to see goes like this, simplest. Between the two pillars, number of tubes or pipes have been put with some gap in between over a stretch of say about 3-4 feet. Now people can walk on this and they can ride on this or drive on this, but hoofed animals, they will never dare to put their feet on this stretch. So as a result, they won't try to enter. So it is such a simple, I will say, design, but serving the purpose what we just wanted to sketch. Let us take a second case. Suppose on a nice sunny day, you feel like going to the nearest park and spend some time sitting on the bench, enjoying the nature and whatever it is. But in India, half the time you will find somebody sitting, sleeping on the bench and snoring, or the benches are occupied by young couples engaged in PDA and no sign of vacating the bench very quickly. Here again, can we think of a system which can be designed so that such prolonged occupancy of the benches is discouraged? Again, we can go for we can employ some chowkidars, but I think in all probability they will be beaten up. The other thing, sophisticated solution, we can put a sensor, a timer, a horn, and some logic under the bench, which after a preset time, after this bench has been occupied, would produce such an irritating noise that the occupants would find it better to vacate the bench. Now, a variation of the above could be CCTV cameras, etc. Now, the problem with this type of solution is the system can be easily tampered, and it is difficult to maintain such a system. Here again, a simple design what I have happened to come across is the bench has been given a generous cylindricity on the top so that nobody will feel like sleeping on it, and anybody sitting on it will feel like leaving after some time. It is so uncomfortable. Now, I must just add a footnote to this, what I have just said, that the basic design process for which this bench has been designed, this was my imagination. Maybe the designer who designed this bench, it was just for the purpose, simple purpose of, so that rainwater doesn't stagnate on this bench. So that is the fun of looking at things in very different ways at the time of conceptualizing something. That is what I wanted to impress on. I also want to tell one thing, that a small twist can make a huge difference in an outcome. For example, we use all urban houses, they have got in the toilet, they have got a particular cistern design, and that cistern design is such that whether you do number 1 and number 2, the same amount of water will be passing through and huge amount of water will be wasted. Can you do something so that at least for number 1 use, you don't waste so much of water? It is like this. It is done regularly in the Western countries. The cistern has got 2 buttons, small one, big one, and the small one can be pressed for less amount of water, and the big one can be put for more amount of water. And one can very well see the utility of this, saving so much millions of liters of water maybe. And a second example is something like this. Everybody, sometime or other, they make use of scissors. Now somebody thought that the scissors must be made better so that it's kind on the thumbs. So he came out with scissors. But probably he forgot one very important thing. There is a statistics that 10% of the world population, they are left-handed. What about their thumb? Their thumbs also need some amount of comfort. Fortunately, some kind soul thought about it, and he came out with right-handed scissors, pair of scissors, and left-handed. This one yellow one is the right-handed, and the left was the right-handed. And it opened up a market also. Difficult to get, it commands good price, but it is a nice thing to have. Let us go to another example. This is a simple coffee mug, and the protruding handle of that mug breaks so easily. In fact, it is a bone of contention between the housewife and her maid, or maybe housewife and her husband, and the husband is of the helping type during COVID lockdown. Now, question is, can we make a mug in which the handle will not break so easily? Now, one can think of, okay, make it out of stainless steel or something, but that is not the point, because the stainless steel will make it so strong that the handle will not break, but thrown at you, maybe it will break your head. We are looking for something through pure design modification. One thing came to my mind. Suppose if I make the mug like this, where the handle itself comes within the outer profile of the mug, and one can say that it has got much less probability of getting broken. So from this, now I go to another example. It is a technical example where what I want to tell is that right in the beginning, if we are misled by our own inertia of thinking, then a lot of things can go wrong afterwards. And we spend maximum amount of time in solving those problems without going back to the beginning, why it went wrong. Here is a 3-point self-centering clamp. Now this 3-point clamp is for clamping round objects, round bars, and being 3-point, it has got a flat anvil and there is a V anvil. So I've got a 3-point. And just for the sake of it, these angles, they look nice. It could be 90 degree, it could be 120 degrees. Suppose I have taken 90 degree. And this is operated by a screw which has got a left hand screw, right hand screw. So as I turn it, this one will be advancing, this will be advancing, maintaining the same center for the round. Now look at this. I have to design this screw. Say the left screw, I take a pitch of 2.5 millimeter. Now before that, let us see, when I change that radius, say from R1 to R2, then the flat anvil moves R2 minus R1. And the V moves by R2 minus R1 divided by sine 45 degree. Now, when I make the screw, here if I take a pitch of 2.5, which is a standard pitch, for the other screw, the pitch comes out to be 3.535. Or if I take a standard pitch 2 millimeter, then this one comes to be 2.828 millimeter. Now, who is going to make this screw of this type of pitch? It is not possible with a normal lathe and all that thing. You have to go for hunt for CNC turning machines and all that. But my point is, in half the cases, probably we'll just run around how to make this screw like this, forgetting what was the point in making it 90 degree. Suppose I make it 88 degree. Absolutely, there is no problem. It will be the it's self-centering. This principle will not be violated. In fact, if I make this angle 90 degree to 88 degrees, say 51 minutes 36 seconds, or if you want, you make it 88 degree and 51 and a half minute, which can be set for making this V. Then if I take pitch 2.5, the other pitch comes out to be 3.5. So this is all to emphasize the point that so many times you have to go back to where we started from and see what is going wrong there, without right in the beginning jumping onto how to solve subsequent problems. Now, after all this, the interesting to look into design. So all I'm saying is it is interesting to look into design in a playful manner at the conceptual stage before getting into the nitty-gritties of, say, analysis, kinematic and dynamic analysis, etc., which certainly are taught at length in the college. Now, the above principles hold good in a serious area like machine design also, which I'd like to demonstrate through a few real-life examples. Now, in the machine design, uh, uh, different parameters are emphasized depending on what we are designing. For example, in machine tool, one has to deal with simple motions, 2 or 3 linear motions, maybe 1 or 2 rotary motions. So motions are simple. As a result, basically the mechanisms are simple, but there is a very important point, that is the rigidity of the total chain of parts, right from the metal cutting machine to this cutting point to the workpiece. So if that is not stiff, then you will not be able to maintain accuracy. So a lot of work goes in making those parts strong, and in the process, many of those, they become under stressed from the normal stress calculation from stress point of view. On the other hand, if I go to packaging machines, then their motions are complicated. As a result, you will find a lot of complicated mechanisms, and there is less emphasis on designing for strength. Now, packaging machines, you will agree that many a time it simulates the motion performed by our hand, fingers, and things like that. Hence, all across the field of packaging machines, the complicated mechanisms, they come almost automatically. However, what I want to say, that even in this world of very complicated, nimble and fast mechanisms, there are so astonishingly simple mechanisms that in the first look, they look almost absurd. I mean, they look surreal. Just give me one example of a cartooning machine. Now, everybody has seen this thing. Once a paper carton gets filled up with, say, a medicine bottle or a toothpaste or whatever it is, then these 3 flaps are to be closed. Now, normally this curtain is moves on a conveyor. Now, my question is, what type of mechanism we have to have so as to close these 3 flaps so that curtain becomes like this? And my condition is that I want to do it by employing a simple mechanism in which is completely static, nothing moves. Now, if you think how I would have closed this thing using our hand and fingers, so it seems remarkable that I can do it by a static part, but it is done like this. As this one moves in the direction of the arrow, the trailing flap, as it goes forward, it comes against. Now this is the okay. This one is the very leading one. The trailing one is gets fixed by means of a simple mechanism. But when I come to this one, this leading flap, when it goes forward, it works against a static part, and as a result, because of the reaction force, it just folds itself like this. Same thing happens if you talk of the lower flap. Here again, a suitably contoured plate is placed, and this flap will be acting against that, running against that. As a result, it will rise, and this one will be tucked in. So both these difficult operations are done by 2 very, very simple parts. I mean, very simple. Just to give you one photograph, here is a curtain, is a cardboard box, and this cardboard box, it moving from here to that side, and then the top of the cardboard box is to be closed, and that is done by making it run simple, most innocuous, humble rod, this, which are called rod switches. So when it is fabulous, when you see that this whole thing is just working at a speed of maybe 200, 250 cartons per minute, and this simple static rod is doing so much, then it is mind-boggling. So that's why I thought this is one example of mechanism or simplicity worth seeing. Now let us go to a slightly complicated area of cigarette making. Now I am considering only plain cigarettes in which there is no filter. That means something like the old Charminer or Panama. Now, you will remember that some of us used to roll our own cigarettes by putting some amount of cut tobacco on a piece of cigarette paper, then rolling the paper around the tobacco, and then securing it with a seam of adhesive. Perhaps we are making one cigarette in a minute. Now, in the 19th century, cigarettes were being made commercially by putting tobacco roll in a paper tube. So that was mainly manual operation with use of some contraptions and things like that. But things changed in 1881 when the continuous rod machine came. This is due to an invention by Bonsack. And continuous rod machines means cigarettes are not being made piece by piece. A long cigarette rod will be made that will be cut to pieces, and that is the invention of introducing continuous rod machine. And that straight away took the speed of making, say, about 250 sticks per minute. Then 1924 to 1957 UK Mullins, they introduced their Mark 1 to Mark 7 machines. And by the time they came to Mark 7, the speed went up to about 1200 sticks per minute, quite a lot. Then almost a revolution occurred. In 1958, Mullins Mark 8 machine raised it to 2500 sticks per minute. And there is one more thing to be kept in mind. So long, the cigarettes which were being made, the density of the tobacco inside the cigarette used to be non-uniform. As a result, it gets extinguished when you are smoking, and that is very irritating. So, not only it increased the speed, but it also gave better quality cigarettes. Now, what is that invention which made this quantum jump possible? And look at the difficulties in doing this thing 2500 sticks per minute. You are handling two inputs. One is that cut tobacco strands, which is disjointed, highly flexible material. And then you are also handling paper tape, thin paper tape, which is also highly flexible material. Now, that paper tape, if you are making continuous rod machine, the paper tape moves something like 200 meters per minute. 200 meters per minute comes from, suppose I am making 80 long sticks at 2500 sticks per minute, then the rod will be moving at 200 meters per minute. Now, this was made possible through this invention, which I have just represented schematically. Now, here is the cut tobacco strands, which is rising through some airflow. And here is the paper tape, which is running like this at a speed of 200. Now, the paper tape doesn't run straight away onto these rollers. In fact, there are a number of rollers on which a soft band runs. And this paper tape, being unwound from a spool, it runs on that soft band of soft band. So it is moving in this direction at about 200 meters per minute. The tobacco strands are rising. Now, a vacuum chamber was introduced with open mouth. This mouth is open. And then, here is the most important thing, that an endless metal tape running on number of rollers was introduced, and this metal tape has got huge number of perforations, and it just grazes the open mouth of the vacuum chamber. So as a result, one can very much easily understand the vacuum, when it is created, the vacuum will reach to the underside of the perforated metallic tape. As a result, the strands, they will be attracted to the underside of this running perforated belt, and it will be hurled forward. And if this belt is running at the same speed as this paper tape, so it will be hurled forward at the same speed as this paper. The moment the belt leaves the region of this open mouth, then the vacuum is gone, and these tobacco strands will gently fall onto this running paper tape. It is something like what you find every day in Calcutta, getting into a running bus or a running local train. So this is what it is. That is how it does. Now, just look at this. There is not much of engineering involved in it, but it is that's the quality of thought, the revolutionary thought, that one can think of a tape, and that tape has got perforations, and it will be running at the same speed as this. I mean, if you think of the problems, it is something like he is solving a problem of needling a thread standing on a cartwheel. It is so. It is. I mean, it is almost. I look at it like this. It is almost a beautiful thought experiment, and it is beautiful. And I 100% sure when the inventor did it, he got a lot of fun and satisfaction out of it. Now, just for the sake of info, this invention was done by a French designer, Lobe, working with a French company, Decathlon, and Moulins UK, they bought this invention from Decathlon, and they also engaged Lobe in their service. And as a result, they brought out this market cigarette, which runs at 2500 sticks per minute in 1958. And just as a matter of information, in India, plain cigarettes today are made at about 3000 sticks per minute. In the West, it is done at 6000 sticks per minute. And Moulins also made 10,000 sticks per minute, that type of machine. But this put a very high demand on the quality of the cut tobacco and the paper tape. As a result, it was not a commercial success. But all these were possible due to that said invention, which is mind-boggling, if you ask me. Now, from these flexible things, now let us go to something very solid. We know everything about, we have heard about these camps and all that thing, a lot of things are taught about camps. Now, a circular weaving machine makes use of a cam which looks like this. This is the heart of the machine. Now, it is a cam, you can see that it is a disc cam with the track which has got 3 lobes. So as a result, if this rotates by one rotation, the follower will be making 3 rises and 3 falls. That is very simple. That means this. Now, if you look at this, if you can see it a little bit, for the cam track, as the R radius increases or decreases, the track also twists. For example, at one section, it is straight. In another section, it is inclined this way. In another section, it is inclined that way. This takes place because the cam followers, they are not making linear motion. It's like this. This cam is engaging these 2 cam followers, and these 2 cam followers, they are mounted on a lever which has got a fulcrum here. As a result, as R changes, this will go on rocking like this. And of course, the track has to accommodate this, the track has to twist this way or that way, which is very clear from there. Now, this particular cam was being imported at a very high cost for a very long time, and about more than 1,000 cams were needed per year. So it was decided that we have to do something about it, and we thought that we have to make rather than going out, we will make a machine to cut this cam. Now, there are simpler methods available. For example, if I take one imported good cam, take it as a master, take it on a copy milling machine, then the copy milling machine taking this one as the master can carve out another cam. Or if you want to be a little more sophisticated, I can take this imported cam to a 3D coordinate measuring machine, where we trace every point of this cam track and make a data cloud, and then process it in such a way it becomes the data to be put in a copy milling machine or CNC 5-axis CNC milling machine, and that will carve out a cam. Now, but we decided, rather than what you call reverse engineer, which if you ask me if you can, I would like to say it is nothing but copying. We wanted to do, take that path. We wanted to make a machine in-house. Now the problem was this. This cam, as you have seen, it is a mathematical surface. But the problem was we were unable to work out the cam profile mathematically from the motion of the swinging follower. Here, let me let out a open secret that with the practicing engineers, after working in the industry for about 3-4 years, we forget all our mathematics to the extent that even if you ask me to solve ax square plus bx plus c is equal to 0, first thing I will do for a numerical method of maybe bisection method or tangent methods, things like that. That is the state of affairs. Now, how do I then design this cam track cutting machine without knowing much of mathematics? We reasoned it out like this. If the two rollers, followers, which can be replaced by two milling cutters. The cutters are made to traverse the same path as the two followers. Then a profile would be cut, which is same as the profile traversed by the followers. It's simple. What I'm saying is something like this. It is analogous to cutting a gear without knowing the mathematics of involute curve. And we can do it like this. For example, I don't know much about involute, but here is a cutter which has involute teeth, but with some modification so that it can act like a cutter. And I make it engage with a blank, round blank. And suppose I want to cut 40 teeth, then I have to, this has got 20 teeth, then I have to make them run at synchronous speed, and this will be running at half the speed as this one. And this will be going up and down, cutting the metal, and also it will be fed in. Ultimately, I'll get a involute a gear with involute teeth. So what we thought, in that the cam followers, let it be replaced by end milling cutter, which of the same diameter at the same place. And if we can make it move in the way the followers are moving, then I should be able to cut the track. Now, so basically it comes to a milling machine with two cutters, which are of the same diameter and at the same position as the follower rollers, and executing the same swinging motion as the swinging lever was designed. Now, how do we do that? So we thought that it itself will be the swinging of the cutter carrying lever will be done by means of another cam, which will be the master cam, and that will impart the motion what we need to that swinging lever cutter. And so the master cam is nothing but a simple plate cam which looks like this with three lobes. And then we didn't forget about totally whatever we learned in the college. I mean, this rises and falls, they can be sinusoidal or cycloidal or polynomial. I think we made use of some sinusoidal or something. I don't remember it properly these days. Now the machine looked like this. Here is the cam I want to cut. Here is the master cam, but we have designed with three lobes. They are put on the same axle and which has got a drive by means of motor. It's independent drive. And then a big strong lever with a pivot here was introduced, which itself carries the two spindles which are carrying the two milling cutters, and they have got their own drive. And this lever engages the master cam through a follower and is always kept in contact with the master cam by means of certain spring systems and all that. So as a result, when I make this one rotate, this one will be swinging and these cutters will be go on cutting this portion of the cam track. That means it will be doing like this. When it is rotating, the follower is keeping in touch with this master cam, and this is swinging, and these two cutter rollers, depending on in what orientation is that, it goes on cutting. So by one turn, I make this cam track. Actually, it's not made by one track. Slowly we close the thing so that cutting load is not too high. So ultimately, the machine came out like this. So all I wanted to say that after knowing, being ignorant about mathematics, like the solid geometry and differential geometry and all that thing, we could manage to make this machine for making this cam. And it was a lot of fun and a lot of satisfaction. Now I just coming and offshoot to that, in another machine, we are making a prototype of another circular weaving machine. And there again a cam, and here the cam is not like a plate cam, it is a drum cam, and here is the track. Now here if this rotates with the theta, then this follower will go up and down. Now the casting looks like this, and in terms of engineering drawing it looks like this. This is a drum cam with a track on it, and there are two two follower rollers. They are on a lever. The lever has got a fulcrum here, and work actually in the machine is done by at this end. There are certain mechanisms attached to it. Now you are going to make just two cams. For that we cannot make our own machine, and this can be made by means of a 5-axis CNC milling machine. Reason being, here is that one coordinate, rotary coordinate theta, there is another rotary coordinate which is swinging thing phi, and then the cutter has to have certain linear motions x, y, z, which is, so that's why a 5-axis CNC milling machine that we needed to make this cam. Now we located one. Now we needed 2 cams. We located on 5-axis CNC milling machine. Now, did that gentleman said, or rather anybody will say, we don't understand what is a cam. You give me the solid model of the part you want to make, and then you give the material. So I will put this thing in my controller of the machine, and the thing will be cut. It is something like Michelangelo is saying, I don't understand what you want to make. You give me the drawing and give me the piece of stone. Then I will just sculpt it out, and then you see whether you are making Pieta or Mother Mary. So it is something like that. Now here the problem was he wanted solid model. Issue was how to draw the solid model of a surface which is mathematical in nature, but we do not know how to handle the mathematics. Same problem. It is a mathematical track surface. So here we did like this. The solid model was prepared in this way. We drew the complete chain of parts right from here, this lever, from here to here, actual parts, the way they are going to look like in 2 size and everything. And also we drew in a solid model package up to this. Only this much was not there. Then what we did, we gave a small swing to the lever, say phi angle, we made it d phi. And we also made the cam body rotate by a small corresponding angle theta, so d theta. So with an angle of d phi, I am just rotated the body to d theta. As a result, I will get 2 contact lines of the cam follower, they are rollers. So I will get 2 contact lines, straight lines which are parallel. And then if I go on doing it many a number of times and covering 360 degree, then ultimately I should get a thing like this. That means depending on d phi and d theta, small increments, I will get these contact lines of the cam follower. And of course, the contact lines is the cam follower and the track. So this is the line which is also sitting on the track. There are in fact 2 lines, one parallel to this which you cannot see, and this one is joined. That means in this way, we managed to make a wireframe model for this track. Now the only thing left was, now it is a wireframe model, but we have to make a solid model. That means we have to fill up all the spaces in between. How it was to be done? Fortunately, we are using Pro Engineer, that solid package is thing, and there is a command. It is called skin. So that with that command, you can put a skin on this wireframe. So as a result, it becomes a continuous surface, and a continuous surface which is something like the solid model what you wanted. And this thing came out like this. So this is the body of this, and this is by that process we got this proper track made like this. This is a solid model. And then of course it was taken to the 5-axis CNC milling machine, and then they machined it. Just as a matter of interest, the machine looked like this. This is the cam blank, and which has been clamped on a rotary table, and this constitutes theta. It is the rotation of the cam body, and this whole thing is on a cradle, and this one rocks like this, so that constitutes the angle phi. And then here is the end milling cutter, which can go up and down, left and right, and in and out. That means the x, y, z 3 axes. Then in the machine, by the manipulation of this x, y, z, and theta and phi, the whole thing could be cut. In fact, this is the finished cam. The bright portion, what you see, that is the cam track, finished cam track. So that way, it was also fantastic in the sense we got a lot of satisfaction. It was great fun. Again, without knowing mathematics, we could manage to do this thing and keep our job. Now I am going to something from metal to non-metal. Now here is one equipment about which I am not going to give any detail because of confidentiality. We are going to concentrate only on this portion, which is nothing but a chamber. This chamber is the body of the chamber, it is a cylindrical chamber. There is a cover this side, there is a cover this side. Now the whole thing is made of plastic. So there is nothing great about it. Now the cylinder is of the 1 meter in diameter and 1 meter long. Now making a chamber like this with say fiberglass is not a great deal, because so many times the acids etc. are carried in tankers where the tanks are made out of fiberglass and things like that. So it is like that. But the problem got complicated elsewhere. This thing chamber has to work in the during operating condition. It will be filled up with inert gas at 5 bar pressure. The moment you do that thing, one can calculate the chamber has to withstand a hoof load of 25 tons on each side, on the each side of the body, and a separating load of 39 ton for the cover. One can very well just on the back of an envelope, one can do this calculation. Now that means now it is not just a container, it is a pressure vessel. Now how to design a pressure vessel? Because if we make pressure vessel out of steel, huge amount of data is available, that is not a problem. But there is scanty data available if you want to make a pressure vessel out of FRP. And I also forgot that I have got a friend, Debiprasad, sitting in New Zealand. So we had to find out our own way out. So we designed in our own way. We had to play with the composition of the fiberglass, the percentage of the glass and everything. Anyway, we made it. The chamber was made, the covers were made, everything was done. The problem came from the fasteners which are holding the end cover. So the problem is like this. We made use of commercially available nylon 66 screws. That didn't work. Then we made specially made fiberglass brackets to clamp these two together. That also didn't work. Now we could import this particular type of screw of high strength screws, but the cost was exorbitant. So we could not do that. So we have to find out our own way out. Now one thought came to my mind. There is a process called pultrusion. Now pultrusion is a combination of extrusion and pull and extrusion. It is something like that you extrude some resin through the aperture of a mold, and through the same aperture you also pull high strength, could be fibers or threads or wires, something like that. So ultimately you get a bar which is having innerly it is just strengthened by means of the high strength elements. So we made this pultruded, we found out somebody who is having a pultrusion plant. Then we made these pultruded bars, then cut threads on both ends, that become the stud. And also we could not get pultruded nuts. So we had to make special FRP nuts, long nuts. And with that, we could just, it worked. And ultimately this thing got done. Now, with that, I come to the success stories which have been great fun. But along with the fun, there are not so fun things when you goof up your design. I'll just give 2 examples. Pitfalls in machine design, just 2 examples. A company was to deliver an explosive slurry filling machine and to a company who are making gelatin sticks. Now you may be knowing what is called gelatin sticks. Gelatin sticks, they are explosive sticks, and basically there is a plastic tube and a gelatin, slurry material, explosive slurry material is put into this, and this the end is just closed with a plastic cap. Why it is called gelatin sticks? Because the slurry what you put into this, the slurry is made out of starch, aluminum powder, and also they put one more reagent which is called cross-linker. And that cross-linker, it cross-links the individual molecules of the starch into a huge molecule. So that becomes gelatinous. I mean, it is very pliable, but you cannot tear it, and it doesn't flow. You cannot make it flow and fill something. So that's why in any case it is called the gelatinous material, but you have to fill it up when the slurry has not become a gelatinous in the gelatinous form. So the machine, we made the machine, And why the machine was before that, the whole process was being done in a factory which is at remote corner of Odisha, and it was being done completely manually by workers who are Adivasi men and women, and they have got no training, but they work like robo. They hold it with hand. This one, take it to a nozzle from which the slurry comes out. When it gets filled up, they put the cap and just goes the finished gelatin stick. Now the machine we made, it look like this. There is an indexing table with a lot of pockets on it. Now here, this side, the plastic tubes will be loaded manually. Then it will come to the filling station. The filling station, basically there is a hopper, and from this 500 kg charge which has been made elsewhere, from there it will be drawn, and here through a nozzle this will be filled up, and after that it will go further like this, come to the capping station. In the capping station, lot of caps are there in a vibratory hopper. From there one cap will come out, and this will be pushed onto the open mouth of this tube. And when it goes forward, this filled tube will be just pushed from inside by a ejector, and it will fall in a bin. So that is the machine. The machine worked all right. The problem was elsewhere. It is like this. The quality of the tubes and the caps, they are horrible. But it doesn't matter. Those ladies and the gents, they used to just hold it by hand, just to get it filled and then put the cap. But in a machine, it doesn't happen like this. Suppose the tube is bent. When it comes here, the nozzle doesn't get in. So as a result, slurry falls outside. Then you stop the machine, clean it up, and then again start. By the time it comes to the capping station, if it is so weak that the capping pressure itself, with that it bends and buckles and bursts, and as a result this gets soiled, you stop the machine, again clean it up. So you go on doing this thing. In the process, a 500 kg charge could not be filled and capped within 1 hour, 60 minutes. And if you cannot do it, whatever remains in the hopper, that becomes, it doesn't flow, you cannot do anything with it, that goes to waste. And that was not acceptable. Now, we said that you get better quality tubes and caps, but it was not acceptable to them because the cost will increase, and it was not acceptable to, it will not be acceptable to the, maybe the contractors and the ultras, and then the machine posed these problems, and ultimately the machine had to be taken back, and the project, it was a development project, and it had to be abandoned. So the lesson is, in an automatic machine, the quality of the inputs is extremely important and must be examined right at the beginning. At the type of conceptualizing the machine, this particular point has to be kept in mind and must be looked at very critically. And then I want to give just one more simple machine example, which I think it is so bad that I will say it is a good example for how not to design a machine. Now, a company reputed for making single spindle automats. If people know single spindle automats, they make in 1,000 small turn parts. And they got an order, bagged an order for supplying an ammunition cartridge case sizing machine. It is like this. And a cartridge case is nothing but a hollow tube of brass with a spherical end, and it is done, made by a drawing process. And when it comes up the drawing process, it is of some extra length, and there is a jagged end. Now this machine has to take one by one automatically these raw tubes, and then taking this one as the reference, it has to, maintaining this length, it has to just cut it so that you get a smooth mouth. And that is all the machine. But in their wisdom, they thought, so the machine has to look like this. A simple machine, there is a spindle, there is a collet, then the raw case is fed from this side, from the right, from a hopper, it goes into this, come to a stop, and that becomes the stopper, come the reference, and then one tool comes and cuts it off, and it falls. So that is the cartridge case sizing machine, simple machine. But in their wisdom, they wanted to modify a single spindle automat, or the single spindle automat machine looks like this. Spindle, through the spindle, a long bar is fed. That bar passes through the collet, and then it comes to a stopper. And that when it comes to the stopper, that becomes the reference. Then number of tools. Suppose I want to make this part, which has got a little thread and then some tarred body and then a shoulder. So after this is done, the round bar, 3 tools will be coming one after another. They are all controlled by cams. And then one after another, same turning will be done. And then the threading will be done. Then parting off, it will follow. So this is the nature of machine. Now we compare what we wanted to make and what we are trying to modify. You can very well see that the nature of the input material is different. They are one by one part will be coming, and here I am feeding a long, nice bar. Then direction of the feed of the input material is different. I am going from left to right, then I am going from the right to left. That also creates a little bit of problem. Then referencing. Here you saw the reference was the stopper was on the right side. From there I am maintaining everything. And here the stopper and the reference is on the left. From there I am maintaining. So everything the other way around. So as a result, so much problem. In fact, machine was first supplied, and then it started giving all the problem at site, and a lot of work was done just to get it going. Unfortunately, this could not be done, and ultimately the machine so designed had to be scrapped, and a new machine designed from first principle had to be made and supplied. So that was the thing. And then the lesson is, in any design, the beginning, that is this conceptualization, has to be in the right direction. I mean, right in the beginning, if you have to go to north and you go south, then course correction becomes very difficult. So if you want to make a cat, better start designing like a cat rather than trying to modify a horse to make a cat. So that is the reason. And these are the 2 examples. And with that, I come to the end of the technical part of my lecture, the main part of my lecture. Then, as I requested right in the beginning, I wanted to take just 5 minutes just to touch on 2 points, and these are like this. In one of the earlier lectures, I think Professor Amitabh Ghosh and Mr. Achyut Ghosh, they had a nice discussion in the sense, and what is the state of affairs of the reunion, that exhibition what we used to have at our time. I don't know what is happening there, but if I remember correctly, this used to be a very important and very interesting yearly activity for we the students who are used to be on say any student. But we at that time 4th year, and there is a 1966, and there 2 machines were made. One is an automatic cigarette dispensing machine. Automatic cigarette dispensing is done by a group of my friends. Muropan, they called this group Muropan. Muropan is Mukherjee, Roy, Purkasto, Pal, and Nag. And they formed this group. They designed it and then exhibited it. And the machine looks something like this. You put a coin into a slot, then press a button, and 1 cigarette will come out. In Calcutta side, the first step of living cigarette is to stop buying packets and buy single cigarettes. So this was made keeping in mind. It was exhibited. It created a lot of interest in people, to the extent that ITC Kolkata got a wind of it, and they lifted this machine and they gave a facelift. In fact, this Wheels 99 and all those things were done by them. And they put it in one of their outlets to gauge customer reaction. It was working, but unfortunately the machine was suffering from 2 defects, which have been described very picturesquely by my friends. The first defect is jam pack. You put the coin, press the button, no cigarette comes out when customer gets angry. And the other problem is jackpot. You put the coin, press the button, lot of cigarettes come out and customer gets delighted. Unfortunately, both this anger and delight, they are not acceptable to ITC. They lost interest. Unfortunately, my friends also, they got busy with their final year thesis, then looking for job, final exam, etc. It died its own natural death. And the second exhibition was an automatic, it is a model, not a machine fully, a model of automatic bowling machine, including which will also impart off spin and leg spin. Now it was designed by a number of us. I happen to be one of the teammates, and I think there are two others. And as luck would have it, it was reported, because cricket being popular, it was reported in local newspaper. We became, Ek Din Ke Liye Raja. So it became like that. Unfortunately, there is no photograph or no drawing existing. But the one thing I have to tell you, that because of immature design, bad manufacture, bad parts, the automatic bowling machine broke down after maybe bowling after maybe 8 to 10 overs. But anyway, nevertheless, it was a lovely thing. We felt that we could design, and afterwards, even today I feel with it could be designed in a slightly different way, and it could be made into a, not only this cigarette automatic vending machine also could be made into a sellable product. But anyway, that didn't happen. But I still remember with a lot of nostalgia and a lot of happiness this what used to happen during our days in the exhibition at the reunion. And then last, I want to touch on the last point is, in his lecture, Professor Amaresh Chakraborty of IISc Bangalore, he mentioned that whether the design course what we are offering in the college can be tailored in such a way so that a few students get motivated, they become passionate about design, and probably in that way maybe 1 out of 10 designer comes out, then that will be a bonus. And there was some lively discussion with Professor Sanjay Gupta also on this aspect. And afterwards, I came to know that now in B college, you have got incubation cell. And then you also have got a lot of money to do this type of activity. Now, all I want to say, what Dr. Amaresh Chakraborty said, I fully agree with that. And to that, I just want to add one more thing. Resources can be made available by the authorities, but the students also, there is certain amount of responsibility on their part. Firstly, they have to remember, even in today's world of technology, pure mechanical engineering can still offer a lot of fun and probably a career option also. But they have to think of a simple thing. Only some, maybe 3-4 efforts are needed from their side, which I would like to put it like this. The first one is, on the slightest pretext, you don't open the internet to see what has already been done. Better make use of your brain. Anyway, how you use your head is that you have to think out and just try to think it out yourself. The second point is, there will be problem, but there will always be some way, and you have to imagine solution. Here, this gentleman, he lost his T-square, but still he is managing the work. You see what he is working with. The third point, what students can keep in mind, is think simple. Here is a linkage, is a long and complicated linkage, very nice, interesting, but perhaps it could be replaced by just a chain and a pulley. So think simple. Last but not the least is be adventurous. This gentleman is telling the two friends, let us design a machine that does absolutely nothing. A very tall order. To design something which does absolutely nothing is not a simple thing. In God's kingdom, whatever is there, animate, inanimate, everything can be made to some use. So this is a tall order, but one has to be adventurous. So with this, I come to the dead end, real end of my talk. And so all these funds are there, and still one more fund still remains, and that is, I offer myself to the mercy of my audience. Thank you all. Thank you very much. And dear chair, I apologize for maybe taking more time than you allotted to me. Thank you.
Sir, unmute yourself. Professor Guha, please unmute yourself.
What is happening?
Yes, now we can hear you.
You can, okay, yes. Now it is up to the audience.
Debiprasad,
Yes, sir.
Achyut here. I
Yes.
am absolutely delighted with your lecture. I could have listened 1 hour more. What is there in 5-10 minutes extra? Don't be apologetic.
Thank you, Dada.
Now, first
Thank you.
thing first, first thing last, whatever.
Hmm.
A small thing, people should not talk about himself, but whatever. I am in the business of designing machines, which is large, not small, very large, weighing 100 tons, 150 tons.
Yes.
Like that. But as you said, Devi Prasad, that there is great fun in ultimately making the design working. Now, we make a, I'll talk for 2-3 minutes more. We make a contour of what we want to achieve. There has to be a problem. Before designing a machine, there has to be a problem to be solved. So we try to solve the problem. But then in designing a equipment, if personally for me, if I achieve 80% of the initial thought process, I thank my gods. I believe in the first edition of the equipment, if one achieves 80%, it's a great job done. But then one has to think, as you have told time and again, to think, to think, and to think, and to solve the problem. I can tell my students that in solving a problem, there is a great fun. There is no fun which can be compared with the creator's fabulous fun while the item works to the thought process. So I may continue to join the discussions as and when it comes, but my first statement is kudos to Debiprasad Palit for such a wonderful lecture. And it is so fun-filled. I mean, he has made the habit of lecturing like talking to the friends. That's a great achievement. Thank you, Debiprasad.
Thank you. I just wanted to emphasize what you have said. It is said that 60%, I think something like that, 60% of the cost of a machine is determined the moment you freeze your design. And maybe the design gets frozen 80% at the conceptual stage, what you mentioned. So that gives the idea that how much stress should be put at the conceptual stage so that the machine becomes a success, even from the point of view of cost. So thank you very much.
Sir, if you permit me, I'll add one more point. A drawing is never finished till the equipment is completely made. The drawing will be changed and changed and changed.
That's true.
The way things happen.
Yeah. Yeah, appreciate that. Yes.
Our learned friend Gautam, I can see the face of Gautam. Gautam is a big boss, IIT director. So Gautam must say something.
No. I'm a very humble person. Palidda, absolutely wonderful, fantastic. Congratulations for such a nice and lively talk. Chudda has already congratulated and mentioned about the excellence of your deliberations. It is simply splendid. Thank you, Palita.
Thank you, Gautam. I just wanted to add, mostly I have dealt with solid objects, but your work is to liquids, and maybe other gases, they are much more difficult to handle. You cannot catch them.
I have to tell you frankly,
Anyway,
Gautam's lecture that day was so difficult to consume.
I'm not going to that. What I wanted to tell,
telling-
even after handling liquid, if you thought that you felt like listening to something about solid, okay, this is, I think, your greatness. Thank you.
No,
Yes.
Palitda, when persons like Achyuta or Amitabhda or Ashokda or you, it is always, you can learn a lot of things. So,
Okay, thank you.
I
Yeah.
always
Okay.
look forward.
Achyuta, in IIT Kanpur, when the students are taken to a factory, so-called industrial visit,
Yes.
obviously I took help of Palit. I took the students to his industry. But it was more the other way around. Palit came and used to give lectures in my course. Because I said, I've never made anything. My things are done only on the board. You have made things that I have seen. So you better come to my course and give some lectures. And students enormously enjoyed. Normally, people from industry, particularly the designers, they can design very good, but they cannot convey it to the others, for the students to understand. And that way, Palit was really an exception. Thank you, Palit.
At the age of
I
82,
would- I would-
I am enjoying. Delightful.
I would just like to add what Ashok told, that I was talking about that cam milling machine, and milling machines are notorious for creating chatter and everything. So they are heaving nearby at IIT Kanpur. I called him over, he came with his instruments, and we did some frequency analysis and things like that to get over that problem. So that way, okay, sometimes I have gone to the college talking to his students, and he has also come to solve our problem on the shop floor. So it is nice and it is fun to have these two-way exchanges.
Great.
Ashokda, I have a complaint because, you could have sort of played a role to get Palitda as our adjunct professor or something. Palitda only gave lectures in your courses or in your subjects, but we did not.
Very selfish, very selfish.
Nani, just let me say what I have got to tell. In Bengali, there is a proverb, Bhagavan jaha karen mongoler jonno. So that I didn't try to be a lecturer or a professor. Maybe the academic world has been saved from my onslaught. I think it like that. Everybody is not cut for every type of job.
But the practical life has been enlarged by your presence and by your participation. But anyway, to all, give me 2-3 minutes. I'll tell you a small story. Please,
Yeah.
Debiprasad, you may like to listen to also. You see, Magnali Bharat, at that time, maybe 10 years, 20 years back, they were quoting 2 years delivery of their gearbox.
Durgapur,
That was-
Magnali, yeah.
No, Magnali Bharat in Calcutta. That
Okay,
is-
Calcutta.
yeah. That was steel plants. 3-4 steel plants are going, maybe 20 years back in India. 3-4 steel plants are going. Everybody was trying to get a gearbox from Magnani Bharat and using in their equipment, and they are quoting 2 years. So what happened? The authorities, the administration, they made a new factory. By the side. They had land, they made it new factory. And they put up a crane. And the moment they started the crane, the whole factory was shuddering and doing a lot of sounds and all that. The union said, we will not enter that factory, new factory shed. And there were maybe 200 tons of forging and casting line there in the factory, new factory, considering that the cranes will operate and the opening period will be such and such. So anyway, somehow they failed. And I, as an idiot, I was called, could you do something? Why this is sounding? I said, okay. Go, let the fool go and ponder. So I went inside the factory. Everybody was there. There is German workshop works manager and all that. So I went there. I thought, please start the crane. And it started shuddering whole thing. Now, please another 2-3 minutes. See, the factory was made in a form of a 2-hinged portal. It's a 2-hinged portal. The bottom of the base is hinged, and then the concrete members, and then steel top. So it's a 2-hinged portal. And then what the crane manufacturer did in his, it's a 10-ton crane or something, they, in their happiness, they put two 10-kilowatt motors on the two sides for the long travel. But the two 10-kilowatt motor was more than sufficient to give acceleration, and it was slipping. So much of rotary acceleration was being provided by 20 kilowatt in the long travel, where maybe 5 kilowatts is needed, that it was accelerating much more than the inertia of the machine could permit it to move. So I just said, okay, let me try. So I told him, look, change the motors from the delta to star. I get 1/√2 voltage, and by voltage the torque will be less and all that. They did change that, and it started, and it was doing beautifully, no movement and nothing. And would you believe it? There was champagne in the workshop, and I got my enjoyment as designer. Okay, here is the story for you. Thank you for listening.
Thank you. Nice. Yeah.
Debiprasad.
Yes.
Yes, there is a surprise visitor for your lecture, Josnamoy Chakraborty from USA.
I was just wondering whose voice it is.
You know, Josna rang me when I was listening to Debiprasad. I told him, don't disturb me. I'm listening to a beautiful lecture. And then he heard, and then he joined. And I am, Devi, you tell him, please, I am requesting him, coaxing him to give a lecture in this series. He's one of the best men in the gears in the world. And he's not listening to me.
Debiprasad?
Yes.
You coax him, you tell him, you order him to give a lecture in this series.
Hey, Devi.
Yes.
This is when I heard that you are going to give a lecture. I could not resist my temptation to attend it. And this is the first complete lecture I have heard from this IIEST. Fantastic. I really enjoyed it. I am very, very proud of you.
Thank you very much.
Congratulations.
It must be 10 in the morning there.
Yes, I was wondering how he could be.
11:30. 11:30.
Thank you very much.
I really enjoyed it.
Debiprasad, my request to you, you
Yes.
tell Josna Moy, that idiot, that he is one of the best gear knowledge man in the world living today. So you tell him he must give a lecture.
Okay.
Yes, you put your weight. I will just to that add my light weight.
Anyway, I enjoyed
He's your
lecture.
classmate. He's your classmate. So you have to do it fast. I can join you in requesting
Okay.
it. Okay.
But he came in between to Calcutta for 15 days.
I know. I spoke to him. Yeah.
I told him, please do it. And you know, it is so difficult. Arey, what do you know if it is so difficult? I told him.
Okay.
Do our students have any queries? No?
A comment to make. First thing is that I'm really sorry. Oh, by the way, I'm Kamal Sarkar from.
Yeah, I know you. I know you. You are 1968 batch, isn't it?
68.
68. I know. Yes.
Welcome, Kamal. Welcome.
Thank you. Actually, I'm very sorry that I could not enjoy all the story, but it is almost like Nai Mama Teke Kana Mama Bhalo, whatever I listen, it was really fun. And it is really interesting. And particularly from design perspective, and you give a very illuminating insight into the design process for the student. That's very important. And since I did not hear the whole story, I cannot tell the whole thing, but two things I picked up from the whole issue, whatever I heard for the last half an hour or so, that it is for the students. One of the most important things the designer do, even here I am in USA, by the way, is that they forget to do the documentation process. And this is a really, really bad deal.
Yeah, I agree with you. Yes.
It cannot, I have to, we designer, we are so excited in designing and getting things done. Oh, okay, I'm done. And walks away. It happens in real life. Normally there is a check and balance, but in student life it does not. So what happens, one student does something and halfway through, or maybe even finished, they walk away, the next student comes, he doesn't know what to do with that. And literally, what I do is that year after year, we, the department, start collecting junks, literally metal junks, year after year. We don't know what to do with that. Okay? Finally, we trash it. So please, for heaven's sake, listen to this thing. Make documentation. First thing. Second thing also, another thing he told, very important. It's very important for the designer as a student particularly. By the way, I'm talking only to the students, okay? The second thing is that do not give your customer a racing horse if he's looking for a load-carrying donkey.
Yeah.
Talk to your
Nice words.
customer. Talk to your customer. Make sure that you are giving them what he is looking for. Okay? And that's why, as Achyuta and Debiprasad told, is that design process is really a continuous process. It's a what we call continuous improvement. Look at your car. Every year comes with a new design. That means the design process is never there. When you accepted the design, that means half of the job is done. That means you got it. You know what to be expected. Then once start the conceptualization, so-called ideation process, then 80% is done. But it's like an asymptotic curve. It never ends. You keep doing it. You keep improving it. So these are the two things that I'm telling you. And for the students, and once again, Debiprasad, it's a wonderful perspective from the designer, particularly, after doing so much design, so many things, making an impact to the industry and to academia also. So it was a fascinating overview and almost what I should say, nilipta bhumika, or just looking at outside how it looks like. It's very, very fascinating. Thank you. Thank you very much.
Okay, fine. Thank you for your comments. And just to add, the problem you have said, making the students write out things. The problem is very much in industry. After the designer has done the design, getting the documentation done in the terms of, say, operating manuals and things like that, that is always a challenge. They have to be really pushed to write the operating manual and things like that. This problem pervades right from the student days to when they are experienced engineers also. Anyway, fine.
Well, Siddhar, do you have any queries?
Actually, in India, this is one course which is normally very badly taught. Theoretical courses are taught very nicely. I mean, like anywhere else, I would say. But design is very difficult to teach. In the sense, very few people have practical design experience who are teaching the course. Like there is a story, one fellow said, I'll design a horse which will fly within 1 year and promised it to the king. The project, after 1 year, when he submitted, the first line said, let there be a spherical horse. The king said, need not say the second line, need not read the second line.
Yeah.
So most of our courses start like that, let there be a spherical horse.
Okay. I feel like adding just one thing, maybe it is directed to the students. In management, we talk of a things, it is called MBWA, management by wandering about. It is like this, if a good manager, he just takes a good stroll, keeping his eyes open in the office or in the factory, certainly if he is observant, he will see number of things which can be changed, which should be improved, and as a result, new ideas will be generated. I personally feel that this holds good even for design by wandering about. If one goes down the street or anywhere, look at things, new ideas come. And if once it becomes a little bit of a habit.
From the department, we are planning From the department side, we are planning to have a conference sort of thing where we can exchange such ideas from seniors, how we can improve our curriculum. Yes, we understand a lot more needs to be done on curriculum, but how to, I mean, it's challenging. I mean, you have
Yeah, anyway, I mean, earlier also
days in year.
a lot of suggestions have been given. So you have to
we'll
put
try
it
to
together.
take as many suggestions as possible, and then we try to have a balanced curriculum if possible,
True.
with inputs from people like you. We'll try to do that soon.
Okay.
Well, Sridhar, is there and close it? Then I would go for Thanksgiving.
Okay.
Chairman. Well, let me take a couple of minutes for just Thanksgiving as responsibility on behalf of the department and on behalf of the Centenary Committee. I must thank Mr. Palit for giving this nice talk. I mean, indeed, it was a fun walk through mechanical design. I mean, the way you put the examples to the screens and I mean, the short anecdotes, it's a fascinating lecture, I must say. I mean, if more students could be here, they could learn something. They could know how, I mean, the way design could be learned through examples and through innovative ideas. I must also take this opportunity to thank our today's chair, Professor Guho, for being with us, for leading the session for more than an hour or so. So thank you, Sridhar. I must also thank members of senior members of alumni who have joined today. Yes, most of you we are regularly getting here in these evening slots every week. So we are really thankful, right, from Achyuta to Kamalda and everybody. Yes, Professor Chakraborty, I got him probably for the first time here today. Thank you very much.
A very slippery person.
Yes, I thought of getting you.
So from my side again, thanks
But,
to
we are also
everybody.
trying to-
Thanks, Professor Guha, and then everybody. I mean, who have come to know them in course of this program. Thanks everybody, and particularly thanks that being so patient when the dinner is getting late.
I mean, I would request our today's chairman, Professor Guho, to virtually hand over the certificate of appreciation to our today's speaker, Mr. Palit. And the hard copy of the certificate should follow with a memento that we have organized. This will try to find opportunity to hand over sometime either in campus or maybe we have to send it through courier.
Just one request. Please don't send through courier because in another 7 days time I'll be going out of Pune and I will not be here.
So that's why
for about
we will be holding it for the time being. Let us look for opportunities.
Just keep that in mind. I'll be grateful.
Let's see if we can make that speakers conference happening sometime soon. That will be another opportunity of getting involved physically within the campus in the department.
Where
So
are
let's
you
plan it.
getting relocated, Palita?
Okay, there is an option B. We have to always think of option A, option B. Another option is if you don't want to hold it on for a long time, you can hand it over to
that we know.
Sri Ashok Mallik.
Yes.
He will keep it for me. It is quite possible. And this is up to you.
Okay, so thank you very much. Thank you, one and all. So
Thank you.
Can close
I
it
also,
now.
from my side again, thanks everybody, my seniors, my juniors, my contemporaries, everybody. Thank you.
Thank you.